Kaylin, Riley, Zelda here, and we're going to do what I call a mixture problem. So there's lots of ways to solve this type of problem, but we're looking at it through the eyes of algebra. And we're also looking at it through the lens of solving one equation and one variable. So let's read it. So Kaylin buys bags of peanut butter dog treats for Riley and bags of salmon dog treats for Cosmo. Sad story, Cosmo actually passed away yesterday. I was going to rewrite this, but we're going to do it in memory of Cosmo. Cosmo's 14 and she had a really good life, by the way. The bags of peanut butter dog treats are $5 each, and the bags of salmon dog treats are $10 each. How many bags of each flavor did she buy if she spent $80 total and bought 10 bags total? Sorry about that typo. Buy should be B-U-Y. So let's pretend it doesn't say B-Y. Okay, so again, we're going to think about how can I solve this using algebra, and I want to make one equation in one variable. But because I have two different pieces of information, so one piece of information is the cost. So I'm going to put cost. So that's one bit of information we have. The other information that we have is the number of bags. So we're essentially going to create two different equations, but we're going to bring them together to make one equation. You could think about this as a system of equations and using substitution, but for right now, we're just going to think about it as we want one equation and one variable. So whenever I look at a problem like this that has lots of words, I also like to draw a picture. It doesn't have to be like a fabulous picture, but just so we can kind of understand what's happening. So the bags of peanut butter dog treats are $5 each. So I'm going to put cost. So I'm going to draw a bag. I'm going to put $5, and that is the peanut butter. And then I'm going to put this one bigger since it's worth $10, and those are the salmon. So I'm going to put S. Okay, and then I'm going to do the same thing for number. So I know that there's a total, so peanut butter, however many I have of peanut butter, and however many I have of salmon, my total is gonna be 10. So I know that the number of them, 10 bags total. So I'm going to put, I added them together. So however many I got of peanut butter plus however many bags I got of salmon, I'm going to have 10 bags total. So that's the number and output of bags. Okay, and then the cost, I know that peanut butter $5 each, salmon's $10 each, and I also know that I'm going to spend $80 total. So when I add these together, I get $80. Okay, so again, from this information, we're going to try to piece it together and make one equation and one variable. All right, so what I could say is that I know that peanut butter plus salmon equals 10. So that's from the second equation. From the first equation, I know that if I buy one bag of peanut butter, I would have $5 or spend $5. If I would have two bags, $10. So basically $5 times however many bags of peanut butter plus $10 times however many bags of salmon I get is going to be equal to $80. Okay, and I'm going to make a little cloud around that because that's kind of the basis of our problem. Okay, but there's one condition, and when I add peanut butter plus salmon together, I get $10. I get 10 bags. So I want only one variable. So if I say that there's 5 bags of peanut butter, then there have to be 5 of salmon. If there's 10 of peanut butter, there'd be 0. So essentially, the number of peanut butter bags is 10 minus the number of salmon. And I'm going to put a little cloud around that. Okay, so I'm going to use my first equation. So we say 5 times, so $5, whoa, times the number of peanut butter bags plus $10 times the number of salmon bags equals $80. And I'm going to use the second equation information we just got, that peanut butter is really 10 minus S.